So we're going to talk a little bit more about factoring polynomials. In this first example, the trinomial 8x cubed minus 6x squared minus 5x represents the volume of a rectangular prism. And if you recall, the volume of a rectangular prism is length times width times height. Determine the dimensions of the rectangular prism. We have 8x cubed minus 6x squared minus 5x. Notice there is subtraction between these terms, so this is not length times width times height, nor is it length minus width times height. What we need to do is change this trinomial, which represents volume, into factored form. And remember, the first rule of factoring is to common factor. So let's first take out an x, and we're left with 8x squared minus 6x minus 5. So that x could be the length, it could be the width, or it could be the height. Next we need to factor 8x squared minus 6x minus 5. So we need two numbers that add up to negative 6 and multiply to give us negative 40. Those magic numbers, or those two numbers, are going to be negative 10 and 4. Negative 10 times 4 is negative 40, and negative 10 plus 4 is negative 6. So we get x, and then in brackets, we have 8x squared minus 10x plus 4x minus 5. So we split up the negative 6x into negative 10 and positive 4x. Next, we factor by grouping. So here's our first group, here's our second. We take out a 2x from the first group, and that leaves us with 4x minus 5. In the second, the only common factor is 1, so we're left with 4x minus 5. Taking out the common factor of 4x minus 5 leaves us with x times 4x minus 5 times 2x plus 1. So we can take our x to be our length, this to be our width, and this to be the height of this rectangular prism. So therefore, the length equals x, the width equals 4x minus 5, and the height equals 2x plus 1. All right, let's look at some more factoring questions. Next one, we have negative 18x to the fourth plus 32x squared. So first rule, common factor. So we can take out a negative 2x squared, and we're left with 9x squared minus 16. For this example, we see that we have a difference of squares, so we can use our difference of squares shortcut. But if you don't know it, we can still factor this by rewriting the expression as 9x squared plus 0x minus 16. Again, we need two numbers that add to 0 and multiply to negative 144. 9 times negative 16. If we square root the 144, we know that the numbers will be negative 12 and positive 12. So we end up with negative 2x squared times 9x squared minus 12x plus 12x minus 16. Again, we're going to factor by grouping. So we get negative 2x squared. The first group, a common factor of 3x, gives us 3x minus 4. And in the second group, a common factor of 4 gives us 3x minus 4, which is great because we have the matching factors. And we end up with 2x squared times 3x minus 4 times 3x plus 4. And again, if you knew the shortcut for the difference of squares, you can start with the 9x squared minus 16, and you could have went right to this step here. All right, next example. This one doesn't have a common factor, but it has this xy and this y squared. As long as the outsides are of degree 2 and the middle degree 1, we can factor this. Just go through the same steps. So we need two numbers that add up to 7 and multiply to 1 times 12, which is 12. And hopefully you see those numbers are 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So we rewrite the x squared plus 7xy plus 12y squared as x squared plus 3. Remember, we're splitting up the middle term, so it's going to be 3xy plus 4xy's combined together give me 7xy's, then plus 12y squared. Same as before, factor by grouping. Take out the common factor of x, and we're left with x plus 3y. Take out the common factor of 4y, and we're left with x plus 3y. Taking out the common factor of x plus 3y leaves us with x plus 4y. So there's our factored form when we have x squared, an xy, and a y squared in the quadratic expression. All right, let's look at some other ones. What happens if I have x to the 4 and x squared with a constant? Well, as long as the outside value, its exponent, is double the middle value, you can factor this expression. So start off the same way. I need two numbers that add up to 5 and multiply to 6. 1 times 6, the outside values. So those two numbers are going to be 3 and 2. Add to 5, multiply to 6. So we end up with x to the 4th, and we're splitting up to 5x squared. So that's going to be 3x squareds plus 2x squareds plus 6. Common factor the groups. So the first pair have x squared as a common factor. That leaves me with x squared plus 3. And the second pair have 2 as a factor. And that leaves me with x squared plus 3. And as long as we follow this method that we've been doing called decomposition, we should end up with a common factor at the end, and then we can factor our expression. So we have x squared plus 3, our common factor, and what's left over is x squared plus 2. In D, we see it looks like a quadratic, but the x squared is at the end and the constant is at the beginning. So you have two options. You can rearrange the equation and put the x squared at the front and put the constant at the end. However, we don't need to do that. We can leave it in this form and still factor the expression. So again, I need two numbers that add up to -1. The b term is still in the middle. And multiply, these two numbers need to multiply to -2 times 3, which is -6. So those two numbers would be -3 and +2. So let's keep it the way it is. So we end up with 3. We're splitting up -x as -3x plus 2x, and then -2x squared. Factor by grouping. In the first pair, we have a common factor of 3, which leaves me with 1 minus x. And in the second pair, we have 2x as a common factor, which leaves me with 1 minus x. Again, this works out without having to rearrange the equation. And we end up with 1 minus x times 3 plus 2x. And finally, E. We have 4x to the 5th y minus x cubed y plus 4x squared y cubed minus y cubed. It looks like a big mess. However, all right, so this expression has 4 terms. But again, our first rule is to common factor if possible. So we see there is a common factor here of y. So we end up with, so if we factor out the y, we have 4x to the 5th minus x cubed plus 4x squared y squared minus y squared. Second thing, we have 4 terms, so that means we need to factor by grouping. So anytime you see 4 terms, we're going to factor by grouping. So taking each of the groups here, here's one group, here's the other. We still have the y spectating out front. The first group has a common factor of x cubed, which leaves me with 4x squared minus 1. And the second group has a common factor of y squared, which leaves me with 4x squared minus 1. We now have 4x squared minus 1 as a common factor for both our terms. So we get 4x squared minus 1 times x cubed plus y squared. Now you may think we're done, but if you look closely, this is called a difference of squares. And this time I'm going to use the shortcut. So I have y. For difference of squares, we just take the square root of the 4 and put it at the front of each bracket. Put an x beside each. Then put a plus and a minus, and then take the square root of the 1, which is just 1. So there is the factored form for 4x squared minus 1. And then finally x cubed plus y squared. And now we're done.